In this video, we're going to practice some pressure conversions and some partial pressure calculations. Let's start with some conversion. Remember, we need to know this, and I'll always give you this on a test. 1 atmosphere is equal to 760 millimeters of mercury is equal to 760 torr. Know that torr and millimeters of mercury are essentially the same. Or 101.325 kilopascals, or 101,325 pascals is equal to 14.7 psi. We're going to be using this in dimensional analysis to convert these different problems we have here. Let's start with the first one, 125 millimeters of mercury to atmosphere. So I'm going to set this up here, 125 millimeters of mercury, and I need to cancel that out. So I know that 760 millimeters of mercury is going to be equivalent to 1 atmosphere based on this. Set this up here, cross them out, cancel it, and I do the math. That's going to work out to be 0.16 atmospheres. So 125 divided by 760. Remember, I use this dimensional analysis. This comes from that stuff at the top. Next one, 2.48 times 10 to the negative third atmospheres to millimeters of mercury. So I'm going to have to do a little bit of conversion to make sure that this didn't work in a calculator, but you can punch this in as well. You just put that in as 2.48 e negative 3. Well, I'm going to essentially just move the decimal point 3 to the left, which is going to convert it into 0.00248 atmospheres. So I'm going to millimeters of mercury, so I'm going to use that same dimensional analysis, only this time atmospheres is going to go on the bottom, and millimeters of mercury, 760, goes on the top. Cancel out atmospheres, and what I'm left with there is going to be 1.88 millimeters of mercury. Same idea for here, 1.76 times 10 to the second. I just move the decimal point 2 to the right there. That's going to work out to be 176 torr. So 176 torr, I need to go to kilopascals, so 760 is going to be equal to 101.325, so I'm going to put torr on the bottom, 760 torr, it's going to be equal to 101.325 kilopascals, cross them off, cancel, and I'm left with 2.35 kilopascals. Next one, 4.75 times 10 to the fourth, just move that decimal point 4 to the right, that's going to work out to be 47,500 atmospheres. I'm going to use dimensional analysis. 1 atmosphere is equal to 101.325 kilopascals. Cancel out atmospheres, and what I'm left with is, oh, that's a big number there. Let's see, 4.812 times, yeah, that's a lot of kilopascals. So I can simplify that, turn it into 4.8 times 10 to the sixth kilopascals. I guess that was a lot of atmospheres there. All right, final one, 5.38 kilopascals to millimeters of mercury with dimensional analysis. I know that 101.325 kilopascals is equal to 760 millimeters of mercury. Cancel out those, do the math, 5.38 times 760 divided by 101.325, and I'm left with 40.35 millimeters of mercury. All of this can be done when I have those conversions right there, which you will always have for tests. All right, let's do the following conversion here. So same idea there, just got a lot more to it. 101.325 pascals going to kilopascals. So remember that a kilopascal is 1,000 pascals. So basically all I need to do here, move the decimal point 3 to the left. Now, for converting to atmospheres, that one's going to be simple. I'm just using this stuff right across the top here. Everything here has been set up. Remember, torr and millimeters of mercury are the same. All that's going to equal to 14.7 psi. Next one, I'll have to do a little bit more math on there. All right, 33.7 kilopascals to go to pascals, that's going to be equal to 1,000 kilopascals. So I'm going to have to multiply this by 1,000 to go out to there. So just essentially moving the decimal point there. Now for atmospheres, I'm going to have to do dimensional analysis. 33.7 kilopascals, I'm going to atmospheres, put that on the bottom there. Kilopascals will cancel out, and it's going to be equal to 1 atmosphere. Cancel out kilopascals, and I'm left with 0.333 atmospheres. Now, for this is going to be kind of a little bit easier to do this since I'm going to be starting with kilopascals for all of them. I don't need to erase the entire thing. I can just erase this top part here. I can keep my conversion. So I'm going to keep this right here. Now I'm just going to substitute in 760 torr. Same idea there. Cancel out the kilopascals. What I'm left with there is 252.8 torr. Same thing there, millimeters of mercury, if you remember, are equal to torr. Now we need to change that to 14.7 psi. Cancel out. What I'm left with, 4.89 psi. So all of those here, I was able to repeat just because I kept that same conversion, just substituted what I had there for dimensional analysis. Let's move on to the next one. 0.830 atmospheres. I'm going to first go to kilopascals, 101.325. Cancel out my atmospheres. What I'm going to be left with is 84.1 kilopascals. I'll write that in. Now to go to pascals, remember I just multiply by 1,000. Erase this. I'm going to put in 760 torr, cancel out atmospheres. I'm left with 630.8 torr. Remember, torr and millimeters of mercury are the same, so I can just copy that over there. Final one, 14.7 psi. Cancel that out. That's going to give me 12.2. Actually, I shouldn't write atmospheres there. That should be psi because I've canceled that out. All right, let's move on to the next one. In this case, I'm starting with 733.6 torr. I'm going to be converting that into kilopascals. 760 is equal to 101.325, pulling that from right up there. Cancel out the torr. What I'm left with is 97.8 kilopascals. To go from kilopascals to pascals, just move that decimal point 3 to the right, multiply it by 1,000. Let's clean that off. Remember, 760 torr is 1 atmosphere, so now I'm just dividing that there. I'm left with 0.97 atmospheres, so just a little bit below what we're used to. Your ears might pop. Let's go to millimeters of mercury, same as torr. Remember, those two are the same. PSI is going to be equal to 14.7. Cancel out the torr, I'm left with 14.2 PSI. 698.9 is what I'm given for this next one here, millimeters of mercury. I'm going to convert that into kilopascals. Set that up there, cancel out millimeters of mercury. I'm left with 93.2 kilopascals. That's some go there. Convert it to pascals, multiply by 1,000. Let's substitute in for atmospheres. Now I'm going to divide that by that. I'm left with 0.92 atmospheres, a little bit higher. Erase that. Now let's substitute in for what we got for torr. Remember, that's going to be the same thing there, torr in millimeters of mercury, but PSI, 14.7. Cancel that, and I'm left with 13.5 PSI. Erase that. Let's do our final set here. Starting with 15.48 PSI, I'm going to be converting that with my dimensional analysis into first kilopascals. Cancel that, 106.7 kPa. Go from kilopascals to pascals, multiply by 1,000. Let's clear this off, convert it for atmospheres. 1.05 atmospheres, so a little bit higher than what you'd be used to. Find that in Death Valley. Converting it to torr, 800.3 torr. That's going to be both torr and millimeters of mercury, and I've converted all of these ones here. Let's do our final set, partial pressure. So if you remember, Dalton's law says that the total pressure is going to be equal to the partial pressure of gas 1 plus the partial pressure of gas 2 plus 3, etc., etc., etc. In this case, the total pressure is going to be 785 millimeters of mercury. And I'm going to be collecting this over water. So the pressure of the water is going to be 21.1 millimeters of mercury. So to get to my gas 2, I'm essentially going to have to do 785 equals 21.1 plus P2, whatever that is. Now just do simple math, subtract that from there. Gas 2 is going to be 763.9 millimeters of mercury. So that is going to be the partial pressure of the nitrogen gas at 23 degrees Celsius that was captured over the water. Here I have another one. Sample of air is taken at 1 atmosphere, convert the partial pressure of oxygen. So there's Dalton's law. Remember, 1 atmosphere is going to be equal to 760 millimeters of mercury. So that's going to be multiple gases there combining into it. So air is going to be carbon dioxide plus nitrogen plus oxygen plus the other trace gases, but we're not going to really count that. Air is going to be 760, so that's 0.285 plus 593.525, that's the nitrogen there, plus my unknown, which is going to be the partial pressure of oxygen. Now I'm solving that just by subtracting it from there. That gives me 166.19 millimeters of mercury, or torr. That is my partial pressure of the oxygen alone. All right. Dalton's law again. So total pressure in this case is going to be 742 torr. The partial pressure of the water is going to be 42.2. And remember, that's only at 35 degrees Celsius. It's going to change. So the total pressure of my unknown sample is going to be partial pressure of X plus the partial pressure of water. Total is 742, partial pressure of X plus 42.2. Subtracting that from 742 leaves me with a partial pressure of my unknown gas of 699.8 millimeters of mercury, or torr. That's my partial pressure of my unknown gas.